Hello, James Flaten here at the University of Minnesota with the Minnesota Space Grant. And I'd like to talk to you for a few minutes about soldering. Soldering means, in this particular context, sometimes called radio soldering, connecting electronic components together using solder, which is a metal, which it has a low melting point. Here's an example of some soldering. You've seen lots of these before. This happens to be a microcontroller. And on the back side of this microcontroller, all that shiny pieces of metal, that's where our components on the far side have poked through and then have been connected to this printed circuit board using solder. On the actual top side, there are some pieces, in addition to the through-hole solder, which we saw on the back side, there's actually some pieces which are surface mounted. I'm not going to be talking about surface mount soldering, but I'll just point out that surface mounted pieces tend to have much smaller soldering pads, and hence that's even more complicated. But this is just a basic introduction to radio soldering, especially through-hole soldering. This is different from soldering for plumbing, also soldering for heavy-duty connectors. Power soldering is somewhat different. There actually are lots of resources out there you can learn about soldering, but I thought I'd make my own. But before diving in, let me just show you one that I like a lot. I call this the soldering comic, and it's easy to find on the internet. It's free and available. Just type soldering comic, it'll come right up. And by all means, get a copy, take a look at that. So let's start by looking at some tools. So this is my workspace, and this is the most basic tool, although I'm not going to actually use this one. This is called a soldering iron, and plug it in and it gets hot. In particular, the tip here gets hot. If you want to use a soldering iron of this sort, make sure you buy one that has a very pointed tip. Sometimes they have chisel tips, sometimes they have pointed tips. And for doing very fine, small-scale soldering, you'll want a pointed tip. On the other hand, I'm not going to use that because I much prefer what's called a soldering station. So I have a soldering station here. A soldering station basically has an iron, and then it has the main unit. And the main difference between a soldering iron that you just plug in and it gets hot and a soldering station is, in the case of a station, you can adjust the temperature. 650 degrees Fahrenheit is a reasonable temperature for doing most lead-based solder. You might have to go up to 750 approximately if you use lead-free solder. I'm going to recommend lead-based solder. I'll explain why in a few minutes. Other things. So here's the iron. I pulled it out of its holder here. So make sure you leave the iron in its holder when it's hot and you're not using it. And there's the tip. The tip should be shiny. And then here I have a sponge. This happens to be a dry metal sponge. You can also do soldering with wet sponges. I much prefer dry sponges. And in fact, you pretty much always want your soldering tip to be not only shiny, but free of any drips of solder. So it's not a drippy thing at all. Wipe off any excess solder pretty much every time you take it in or out of its holder. And then, of course, here is the solder. So solder is a very flexible metal which has a low melting point. And if I were to touch the solder to the tip of the iron, see if we can see this, hopefully you can. Yep, there it is. It's melting. And it's smoking. The smoke actually comes from a chemical called rosin, which is in the solder. And so rosin is a chemical to clean the surfaces that you're going to be soldering on. So it's good to have rosin core solder. But now that I have a drip, literally, of solder on the end of my tip here, I'm going to wipe that off because I don't want that. We'll explain in a minute how you actually apply solder. That's not how. Here's some other, let me just turn this off for a moment and just point out some other tools that you'll need if you're going to be doing soldering. You'll need a wire clippers of some sort, and you'll need a wire strippers. Okay, wire strippers come in a variety of types. Here's another one. So this particular wire strippers, the idea is to take the plastic insulation off of the wire. And so you just close it until you have cut through the plastic insulation, but not through the metal, and then you pull. And that takes a little getting used to. It's all too easy, frankly, to close too much and cut through the metal also. So this is a little more expensive, probably a better way to go. And that is something which will stop closing. Oh, how do I hold it? Right here. So the idea is it stops closing at specific sizes, and then you can just say, oh, I'm using 22 gauge wire. I should put it into that second to last hole. And then when I fully close it, it will take off the plastic and it won't actually cut through the metal. So you'll need a wire clipper to clip wires and a wire stripper, perhaps one of these two. Other things that would be useful to have. One other thing, at least, would be a helping hands. So a helping hands is something that has little alligator clips, which allow you to hold onto your pieces. So here's perhaps a piece that I might be doing some soldering on. And I can hold that, which allows me to use both of my hands to do other things. In fact, I'm going to use my right hand to hold the soldering iron and my left hand to hold the solder, which basically means that I need some helping hands to hold the piece that I'm working on. Another thing that's actually very useful to have around when you're doing soldering is called a solderless breadboard, which you might think isn't for soldering, and that's true. If you're building an electrical component using this, you don't use solder, but this is a very handy device for holding onto any part that can plug into a solderless breadboard, and of which there are many, like headers, for instance. So I use this a lot. Sometimes I use this more than the helping hands. Those are the basic tools. I'm going to make a second video. Call this the basics video, and I'm going to make a second video. And in the second video, I'll show you a few more tools. But these are the basic ones. So let's talk a little bit about safety. So soldering is very safe, but you have to be reasonable, okay? So for instance, you're using an iron. The iron is hot, especially this part of the iron is very hot. Don't touch yourself, don't touch your partner with the business end of the iron. And when you're not using the iron, put it in its container so that nobody can bump into it or back into it or something like that. So burns. If you were to touch that or have it touch your skin, it would burn you. That's definitely a safety issue. It's easy to avoid, just don't let that touch you. Possibly even worse than that, not that that was that bad, is the possibility of something getting in your eyes. And so you're using melted metal. And so if that melted metal were ever to become airborne, and that's easy to avoid too, just don't shake your pieces and let the melted metal fly around. But it could get into your eyes. You could wear safety goggles for sure. I know very few people who wear safety goggles when they're soldering. I know plenty of people, myself included, who wear glasses naturally, and that's really adequate for soldering. But if you don't wear glasses, and if you wear contacts in particular, you might be well advised to wear safety goggles while you're soldering. It's a good practice. It's just not done by a lot of people. And that's to avoid things possibly flying around, getting in your eyes. And so there are two circumstances when things might fly around, both of which are very avoidable. One is, as I already mentioned, it used to be the way to clean off something like maybe a soldering iron was not so much to wipe it on a sponge, but to shake it and just shake off the solder. And that does work, and it's a bad idea. Don't do that, okay? Because the solder will fly around and it will be molten and it will burn or damage the things that it hits, although it will cool very quickly. The other thing that actually I've been told causes more injuries in soldering than flying around pieces of molten metal, which does not sound fun, is flying around pieces of wire. And the reason is, remember this thing? The idea is at some point you're going to be clipping your wires, in particular if you have long wires that you're finished soldering and you want to cut off the excess so they don't inadvertently touch each other and cause an electrical short. When you clip a wire, it will fly. And so the key, this is also not hard to prevent, is cover up the clippings every time, or hold on to the clippings every time, just to make sure they don't fly around and certainly don't get into your eyes. There are two other issues with respect to solder, and you saw both of them when I was just using the solder just now. One is that solder often has lead in it. It turns out that lead solder melts at a lower temperature and produces better electrical connections. And so I actually, and most people that I know, use leaded solder. It's often 60-40 lead tin mixture. If you want to use non-leaded solder, supposedly it's safer because it doesn't have lead in it, but the problem is you have to use a much higher soldering iron temperature, so burns become more of a problem with non-leaded solder. And electrically, it just doesn't work as well. So wash your hands. This is always a good idea. Wash your hands, and so you don't interact with the lead. If you've been handling solder and so you get some lead on your fingers, it's not bad for you, but you should probably wash your hands, especially before you eat anything. Also, I mentioned that the solder itself has inside of it, it's hard to see, this is 0.032 inches thick, a fairly fine wire, very flexible, not brittle at all. And Inside of the middle of it, it has a core. It's called rosin core. And so the rosin actually is this chemical which will clean things. And so when you melt the solder, you see smoke. Best not to breathe in the smoke. It's not terrible for you, but it's not great either. So try to stay away from the rosin smoke and try to, as I will, wash your hands when you're done. Those are a few very basic safety things. Keeping those in mind, you should be fine with soldering. Let's go back. Let's actually do some soldering. Okay, so here are the parts. These are parts to a kit, and this is a kit I use to help people learn to solder. And let me just look at these parts a little bit. First of all, there's the printed circuit board. So the printed circuit board is plastic, and it has drawn on it metal traces. So those metal traces actually connect the various holes, and we're going to put our components through those holes. We'll actually put the components on the back side, poke them through, and then solder them on this side, okay? And typically I would maybe use a helping hands to hold that while I'm doing it. Of the components, here are a couple light emitting diodes, and it's very important to get those in the right way around. When you have a brand new light emitting diode, the two leads aren't the same length. And so this is a polarized device. You have to get it in the right way. The longer lead is plus. But of course, once you clip off the leads, then you can't tell what was originally the longer lead. So you better have some other way of telling what's plus and minus. And there are two other ways, one of which works and one of which doesn't. The way that works is if you look right along the edge here, the bottom edge, there is a little bit of a lip, and that lip is flattened off. It's flattened off right on the top side. And so right now it's flattened off. Let's see if I can zoom in on that. Maybe, maybe not. Okay. Probably hard to see that, sorry. It's flattened off on the negative side. So basically it's flattened off opposite the longer lead. Get this back in focus here. There we go. So that's a good way to tell. If you can't tell because the leads have been cut since they were manufactured, you can find the flattened part of that lip, and that will be the negative side. On the other hand, here's something you probably shouldn't do, and that is look inside. And the reason I say don't do that is because inside there's some features, and those features are similar between different LEDs, but different between different manufacturers. And so if you say, it looks like a Gulf flag, and that's the positive side, that is actually not always true. Some manufacturers, the Gulf flag side is positive, and some it's negative. You can't really tell. Go for the edge, the flattened edge. That's the best way, really it is. Okay, other things I have here in this kit, a couple resistors. Those are not polarized, so they can go either way. You don't have to worry about plus and minus for those, but you do have to do so for the light emitting diodes. Here's a capacitor, and this particular capacitor is polarized and has a negative sign right there in light colors. So make sure when you put it into the circuitry, you put that on the negative side. It will be indicated in the instructions, which is the negative side. This is how I'm going to connect it to a battery. Here's the chip that makes the LEDs flash on, off, on, off. This is a flasher circuit. And not unexpectedly, the chip its orientation makes a big difference. And so in this particular case, you can see a little tiny, it's a little hard to see here. There's a dot, there's a circle right in that corner there. And so that corner will indicate, that circle will help you figure out, is this pin number 1 or is this pin number 8 as you count pins all the way around the device. One thing I've added to this kit, it didn't come with one, is a socket. So the socket actually, if you take the socket and solder that in, then you can plug the chip in, and if anything goes wrong, you can take the chip out and replace it. Once you have soldered a chip in, it's almost impossible to get all 8 of its legs fluid enough at the same time to get it back out again. So I much prefer plugging in chips into sockets, even though it's a few pennies extra. It's no more soldering, you have to solder something. And then the nice thing is, when you solder pieces, you want to try to keep them from overheating, and chips are much more susceptible to overheating than most things. So you can solder this sort of at your leisure and then put the chip in when everything is good to go. So here's what I'm going to do, a little bit of soldering. So first of all, let's just take a look at this piece. And there are instructions. And so I'm not going to do the whole thing, but I'll do at least a little bit. I can tell where the chip is going to go. It's going to go right here in the middle where there are those 8 holes. And I want to put it, and of course it's not the chip, but it's the socket I want to put it in from the back side. So now it's placed, it's in place, and each of its leads are sticking out just a little bit, okay? So in this particular case, for instance, what I might do is I might use the helping hands to hold it in place. So there it is, I've clipped it in place. So the socket is there, it's being held, and maybe it is, and maybe it's not completely level, but it's basically in place. And so here is how I want to proceed to solder it. I need to add solder to each of those pads so that the solder covers the pad and also flows and covers the lead that comes through the hole. Here's the rule though, and that is solder never goes any place that's not hot. So the key for soldering, turn on my soldering iron and get ready. The key for soldering is to use the iron and touch both the pad and the lead, the wire, until they're both hot. That only takes about 2 seconds or so. And then bring in the solder. And then the solder will spread around quite naturally, all around, only the things that are hot. So I have my iron in one hand. I have my solder in the other hand. I'm going to just touch them together and make sure it is, in fact, has been on long enough to melt solder, and it's good to go. That maybe takes 15 seconds or so with this particular soldering station, as opposed to a soldering iron. I'm pushing this so it's actually touching the ground. So that means if I push down on it with my iron at all, it won't back away from me. See if I can get my focus any better. There we go. Let me even get closer. And now let me focus. Not too bad. Okay, so here we go. I'm going to clean off my iron because I don't really want any solder on it. This is, I talk about peanut butter application. You put peanut butter on your knife and then you spread it on your bread. That's absolutely not what you're trying to do here. What you're trying to do here is use the iron to get something hot and only then bring in the solder. So I'm going to touch this first pad, both the pad and the wire, the lead, and then I bring in my solder and I melt maybe approximately ½ centimeter or so of solder. And that's all there is to it. Let me do the next one. And let me do the next one. So I've done 3, a total of 8. I'm putting away my iron. Let's see if we can get an even closer view of how that worked. Not too bad. So the idea is the solder has piled up on each of the pads. Notice that it spreads around on the trace because the trace is metal. Sometimes the traces are exposed like this. Sometimes they're inside the board, then it won't spread around. But the key is to get enough solder to make a good connection, but not so much that you would bridge between 2 adjacent pads that are not supposed to be touching each other electrically. In the second video, I'll tell you a little bit about how to get solder back off again, how to de-solder something if you get too much on. But this actually looks good. And if I look at the front side, it looks like it's pretty much sitting down neatly. Here's one thing that you can do, and that is you can solder one corner of something like this, and then if it's not quite flush, you can use your fingers to push it into place while you melt the solder in the backside. That's called reflowing it. So just get it to be liquid and then push it in deeper and then let it sit, and it will rather promptly cool off. And then it will be held in place by that first spot, and off you go. So let's talk a little bit about some of the other kinds of components here. So I just put on one component. Here's another possible component. There's the capacitor, okay? So on this particular kit, you know, I wish I'd had the instructions with me. They're nearby. Let me remind myself where the capacitor goes. So I'm just looking at the instructions here. This is, the instructions will show the side that the components are going on. So I can see that the capacitor is supposed to go through 2 holes, right there and right there, and it even labels plus and minus, okay? So let me just put the capacitor into those 2 holes right now and just show you how you might approach this kind of a component. First of all, I need to get the plus on the right-hand side and the minus on the left-hand side. I push them through the holes. So there they are. And then I push it down as kind of as far as I want to go, which might be about like that. And here's what I'm going to do next. I'm actually going to bend the leads out, or I could have bent them in. But what this means is now that the leads are bent, it won't fall back out again. And that's good because when I turn it upside down to do the soldering, I don't want the thing to fall back out again. And now I can use my helping hands, and I don't even have to hold the component. I can just hold the board and then go ahead and solder those two pads. So check my focus. Here we go, pad 1. Touch the pad and the lead both. Bring in the solder, and it said to flash around. Sometimes after I've gotten it to flash around, I intentionally melt it and draw it up the lead so as to make a nice clean fillet. And then let me just do the second one. And I'm done. Once you take the soldering iron off, the thing will remain hot, but only for a few seconds. So now when I look at that, that component is in place. Those fillets look okay. Ah, very nice. Maybe even a little bit more solder than I would have had to put. But here's a problem, and that is these leads are long and sticking out, and it's possible if this thing were to be handled, they could inadvertently touch each other, and then electrically this would be not doing the right thing. So now's the time to clip the leads. Okay, so here I go. I'm going to clip the leads in this case. Since the leads are easy to hold on to, I'll just grab the leads and clip them. Otherwise, I could have covered the leads and clipped them. Either way, just make sure the leads don't fly around. So now I've clipped off those leads. And notice the leads on the original socket, not all of which are soldered yet, they don't stick out very far, so I probably wouldn't even bother clipping those off. So those are two components. There are some more components to finish up this particular project. But that's an idea of how soldering proceeds. Again, be quick so that something like an integrated circuit, a chip, doesn't overheat, or use a socket so that it actually isn't exposed to heat at all. And then also bend the leads so that things hold themselves in place. And avoid getting so much solder on that the solder spreads out and causes bridges. I think that might be enough for a basic soldering video. I'll make a second video which has tips for slightly more advanced topics.